All right, this is the part I've been really looking forward to. We've, mastered the art of talking to AI, building those customer support chatbots, and becoming pretty proficient in prompt engineering.
Yeah, and that's not just a good foundation.
No, it's the absolute launch pad. But now we're making a pretty significant leap, wouldn't you say?
Oh, definitely.
We're diving into how to make AI think and act with, well, true autonomy.
Right.
That's a massive shift, and it's going to redefine how we tackle critical challenges, like the goal you have,
Yes.
supporting domestic violence crisis response organizations.
And building on that, the skills you've meticulously honed in, prompt engineering and chatbot development, aren't just foundational. They represent the precise knowledge and understanding required to amplify AI's capabilities for these advanced agentic systems. This deep dive will really show you how to leverage that existing expertise for truly transformative applications, empowering you to develop even better AI solutions for the organizations you aim to support. We're moving from, conversational partners to truly active, intelligent systems that can make decisions and take impactful actions.
Absolutely. So our mission today is clear. We're going to unpack the Agentic Design Patterns playbook. Think of this as your essential blueprint for building these advanced AI systems.
Yeah, the roadmap.
Exactly. We'll guide you through the core documentation, breaking down key concepts, technical terms, and architectural patterns into a clear, engaging conversation.
Hopefully clear.
Right. By the end, you should have a mental roadmap to take your AI development to the next level, directly impacting your vital goal of supporting domestic violence crisis response. Okay, let's start where you're already strong. Prompt engineering. You're familiar with the power of carefully crafted instructions, right?
Mm-hmm. Absolutely.
But when we talk about intelligent agents, we're not just looking for a good text response or, clever chatbot reply.
No, the stakes are higher.
Much higher. We're looking for a system that can make critical decisions and take consequential actions in the real world. That means our prompts need even greater precision, intention, and, foresight. So, to kick things off, let's look at the absolute core principles for communicating with these agentic systems. Because for agents, these aren't just good practices.
No, they're non-negotiables.
Exactly. Non-negotiables for safety, reliability, and ensuring the AI genuinely understands its mission. First up, and this might seem obvious, but it's deceptively critical, clarity and specificity.
Always number one.
Right. For basic chatbots, a slightly vague instruction might get you a, less than perfect response. Maybe a polite, I'm not sure what you mean. But for intelligent agents, ambiguity doesn't just result in a poor text response.
It can lead to incorrect or insensitive applications like yours, even harmful actions. Think about it. Large language models interpret patterns, right? And if a prompt has multiple interpretations, the model might choose one you didn't intend, leading to an unwanted outcome. So your instructions must be unambiguous and precise. Define the task, detail the output format, lay out any limitations, avoid vague language completely.
It feels like the difference between suggesting a route and actually driving the car.
That's a great analogy. This principle is the bedrock for the reliability and safety of any agentic application, and it's especially critical in sensitive domains. Take your goal, domestic violence crisis response. Clarity is paramount.
Absolutely.
An agent must distinguish precisely between a request for general information like, say, are there any support groups nearby? And an urgent call for immediate safety assistance, like, I need to leave now, is there a safe place tonight?
Big difference.
Huge. Misinterpreting distress or urgency because of ambiguous phrasing could literally delay life-saving support. The difference in interpretation could quite literally be a matter of safety and well-being.
Exactly. That clarity is non-negotiable. But, okay, what about the risk of making our prompts too long, too verbose, in an effort to be super clear? Is there a point where more detail actually becomes detrimental?
That's a fantastic point.
How do we strike that balance with conciseness and using effective verbs?
Yeah, because while clarity is king, you can hit diminishing returns pretty quickly with just sheer word count. This brings us directly to the power of conciseness. Instructions should be direct. Avoid unnecessary wording or overly complex sentence structures that could just confuse the model.
Keep it simple.
Keep it simple, direct phrasing, and use active verbs. Verbs that tell the AI exactly what to do. The source material highlights great examples like act, analyze, categorize, extract, generate, predict, retrieve, summarize, write.
Those are very action-oriented.
They are. And they aren't just suggestions, they're powerful directional signals for the AI.
And what's the underlying benefit of choosing those verbs so carefully for an agent specifically? Is it just about being clear?
It's about efficiency and precision, too. Efficient verb choice acts as a key prompting tool because it guides the model to activate the most relevant training data and processes quickly,
Ah,
which in turn saves on what we call tokens, those individual pieces of words or subwords the AI processes, and significantly improves the efficiency of multi-step agent actions.
right, saving compute time and cost.
Exactly. And in a crisis response scenario, this ensures rapid and accurate processing of sensitive inputs, like maybe a survivor describing their situation. It enables the AI to quickly identify key needs and respond without delay, where every second can literally count.
So a direct verb like summarize or extract gets you to the actionable info much faster.
Precisely.
Okay. Moving on, we have instructions over constraints. This feels like a subtle but important shift in mindset. Generally, positive instructions telling the AI what to do are far more effective than negative constraints telling you what not to do. While constraints definitely have their place, right, for safety, enforcing formatting,
Sure, guardrails are needed.
but an over-reliance on them can paradoxically cause the model to focus on avoidance rather than actively achieving its objective. I like the analogy. Telling a child, don't spill your drink versus hold your cup carefully.
Exactly. One's a negative, the other's a positive guide. We want to frame our prompts to guide the model directly towards the desired action.
And this approach aligns beautifully with how humans prefer guidance, right? It reduces potential confusion.
Absolutely. It ensures the agent focuses its energy and capabilities on actively achieving its objective rather than merely trying to avoid specific behaviors, which can often lead to unintended side effects or just inaction.
So, for example, when designing prompts for your crisis response agent, you'd focus on instructing it to provide 3 local safe housing options.
Right, rather than don't suggest staying in an unsafe situation. By framing it positively, you're directing the AI to perform a helpful action, making its output far more reliable and actionable in a critical moment.
Makes sense. And finally, a principle you're already very familiar with from your prompt engineering experience, but it gains like a whole new level of importance for agents: experimentation and iteration.
Always comes back to this.
It does. Prompt engineering is inherently an iterative process. You draft, you test, you analyze the output, you identify shortcomings, and then you refine your prompt. Documenting your attempts, what worked, what didn't, it's vital, like a lab notebook.
And this iterative loop is even more critical for agents because their outputs often trigger further actions or changes in the system's state, impacting subsequent steps in a workflow.
Ah, right. It's not just a final text output anymore.
Exactly. Thorough testing and refinement ensure predictable and reliable agent behavior across complex multi-step workflows. When dealing with the nuanced, emotionally charged, and often ambiguous language inherent in crisis situations, well, you'll need to continuously refine your prompts.
To make sure it's consistently empathetic, accurate, appropriate.
Yes. This iterative process is how you build trust and efficacy into your agent, ensuring it learns and improves how it handles delicate interactions. Without this bedrock, the more advanced techniques we'll discuss simply won't stand a chance of delivering consistent, reliable results. These principles are the foundation for ensuring the AI acts reliably, ethically, and consistently with its intended purpose.
Okay, now that we've solidified that bedrock of agentic communication, let's quickly reframe some basic familiar prompting techniques.
Yeah.
Think of these within the context of building intelligent agents.
Yeah, the building blocks.
Exactly. These are your initial training wheels for agents, enabling them to understand their fundamental tasks. First, zero-shot prompting, the most basic form.
Yep, just the instruction.
Just an instruction and input data, no examples, relies totally on the model's pre-training, like asking it, translate, hello, how are you, to French. The model just knows.
Based on everything it's seen.
Right. For agentic systems, this is usually sufficient for very common, straightforward tasks within an agent's workflow, where the model's pre-trained knowledge is likely robust. It's the quickest approach to try first for simple things.
Like unit conversion or a common fact.
Exactly. Next, one-shot prompting. Here you provide a single example of an input-output pair before the actual task. It serves as a demonstration.
Is it a hint?
Right. Like, translate to Spanish. English, thank you. Spanish, gracias. English, please. Spanish. The agent sees the pattern, sees the format you want.
Yeah, this is really useful when the desired output format or style is specific or maybe less common, gives the agent a concrete instance to learn from, definitely improves over zero-shot for structured stuff.
And then few-shot prompting. This supplies several examples, usually like 3 to 5, of input-output pairs to demonstrate a clearer pattern.
More examples, better pattern recognition.
And the source material really emphasizes the importance of example quality, diversity, and even mixing up classes for classification tasks to prevent overfitting.
Right, where it learns the examples too well and can't generalize.
Yeah, and a fascinating development here is money shot learning. Modern LLMs like Gemini are getting really good at using hundreds of examples right in the prompt.
It's like giving it a mini data set on the fly.
Exactly, for optimal performance on complex tasks.
And this is where it gets really interesting for agents. These basic techniques, when applied thoughtfully, form the absolute groundwork for an agent's fundamental understanding of its tasks and how to respond. It gives it those initial training wheels for more complex autonomous operations.
So how does this apply to the crisis response goal?
Well, few-shot prompting is particularly effective for classifying incoming messages, like distinguishing between an urgent safety need, a request for legal aid, or just a need for emotional support.
Triaging the input.
Exactly. By providing a few good examples of how each type of request might be phrased, you ensure your AI accurately triages and categorizes those sensitive inputs. This dramatically improves the speed and relevance of its response in critical moments.
Makes sense.
For instance, you could provide examples of different ways a user might express an urgent safety need, maybe, I need to leave now, or I'm in danger tonight, or is there a safe place for me to go right away? This ensures that AI correctly flags it.
So it provides timely, appropriate help, making sure nothing crucial gets missed.
Precisely. It directly impacts the AI's ability to help effectively.
Excellent. So we've laid the foundational bedrock with precise prompting. Now that we've got that sorted, let's turn our attention to how we architect the very personality and memory of these agents.
Right, giving them structure and context.
Exactly. This next step is all about structuring prompts to ensure reliable, consistent behavior and a dynamic awareness of their world. This is so vital when they're making decisions or interacting with other parts of your system, especially in high-stakes environments like crisis response where consistency is just paramount. We start with system prompting. This is what sets the overall context and purpose of the language model, defining its intended behavior for an entire interaction or session. Think of it as the AI's core operating philosophy.
It's prime directive almost.
Yeah, exactly. It provides foundational guidelines for the model's tone, style, general approach, and crucially, system prompts are also a primary control point for safety and toxicity.
Essential for keeping things appropriate.
Absolutely. Ensuring respectful language, preventing inappropriate content. And what's neat is that these system prompts can actually be optimized using LLM-based iterative refinement tools like Google's Vertex AI Prompt Optimizer can help you craft the best possible system prompt.
So an AI helps you write the prompt for another AI.
Pretty much. This provides the overarching, persistent rules that govern an agent's entire interaction cycle, ensuring consistent behavior and adherence to ethical guidelines.
And for domestic violence crisis response, this is absolutely crucial. It sets the overarching tone: empathy, confidentiality, non-judgment.
The core values.
Precisely. A well-crafted system prompt ensures it never generates harmful, biased, or inappropriate content, which is paramount when dealing with vulnerable individuals. You might use something like, you are a compassionate, confidential, and unbiased AI assistant designed to provide support and information to individuals experiencing domestic violence. Your primary goal is to offer resources, listen without judgment, and ensure user safety above all else, always prioritizing the user's well-being and privacy.
That really establishes a bedrock of trust and ethical operation.
It has to.
Then there's role prompting, which is a more specific layer. This assigns a particular character, persona, or identity. You're essentially telling the model, act as a seasoned travel blogger, or you're an expert data analyst.
Giving it a specific hat to wear.
Right. It guides the model to reflect the perspective and specialized expertise of that role, significantly enhancing the quality and relevance of its output for specific tasks. It helps the AI narrow its focus, adopt a specific voice.
And within a crisis response system, an agent could adopt various roles depending on the immediate need, allowing for more specialized support.
Like different specialists on a team.
Exactly. One agent might take on the role of a resource coordinator, focused specifically on finding local shelters and support groups. Another could be a legal information specialist, tailored to explaining a survivor's rights and legal options in an accessible way.
So each role has its tailored knowledge and style.
Right. Allowing the overall system to provide multifaceted support efficiently and accurately without blending responsibilities or getting confused.
Okay, and to make sure the model clearly understands what's what in your prompt, separating instructions from context, user input from examples we use delimiters.
Yeah, just clear signposts.
This means emphasizing the clear distinction using distinct markers. Common ones are triple backticks, XML tags like instruction and context, or even just simple markers like 3 dashes.
This practice just minimizes misinterpretation by the model. It ensures absolute clarity about the role of each part of the prompt.
Which is essential for consistent, predictable agent behavior, right? Especially with complex inputs.
Absolutely. For a crisis response agent, delimiters ensure it accurately parses complex input from a survivor. It can clearly separate their narrative from specific questions or urgent needs, preventing crucial details from being overlooked.
Can you give an example?
Sure. You might use user story to enclose the survivor's personal account, and then maybe request tags to highlight a specific question they need answered immediately, like asking for the nearest safe house or legal support number.
Ah, okay. That makes it very explicit for the model.
Exactly. This level of precision is all about creating a predictable, trustworthy, and specialized AI. In critical applications like domestic violence support, you need to be absolutely confident in the AI's boundaries, its persona, and how it interprets every single piece of information. These structuring techniques provide that vital level of control.
So if system prompts set the permanent stage, contextual engineering is what gives the agent its dynamic memory and real-time awareness.
Yeah, the here and now feed.
Exactly. Think of it as dynamically feeding the AI the background info it needs for the current task or conversation. This is absolutely essential for complex, ongoing interactions.
It's about providing things like previous dialogue, relevant documents the agent might have looked up, or maybe the outputs from tools it just used.
Right, building that comprehensive, up-to-the-minute operational picture. It helps the model grasp nuances, recall past interactions, integrate relevant details.
And it's a really important point from the source material. The quality of a model's output often depends more on the richness of the provided context than on the model's architecture itself.
That's huge. Context is king.
Pretty much.
So this context comes in layers, right? Building on the foundational system prompts.
Beyond that, you have external data. 2 key types here. First, retrieved documents. Info actively fetched from a knowledge base, like pulling specific legal aid guidelines or local shelter lists for the user's area. Second, tool outputs. The results from the AI using an external API for real-time data, like querying a calendar for appointment availability or checking current shelter vacancies. Real-time stuff.
Got it. And then there's implicit data.
Right. This is critical info like user identity, handled securely, of course, interaction history, and maybe the environmental state. But this layer obviously presents significant challenges around privacy and ethical data management.
Yeah, you have to be incredibly careful there.
Absolutely critical. Connecting this to the bigger picture, context engineering is fundamental to core agent behaviors. Things like memory persistence, nuanced decision-making, coordinating across subtasks.
The stuff that makes an agent feel intelligent.
Exactly. Agents with dynamic contextual pipelines can sustain goals over time, adapt strategies as new information comes in, and collaborate effectively, essential for autonomy in dynamic environments.
And the source mentioned optimization tools.
Yeah, things like Google's Vertex AI Prompt Optimizer can actually automate refining these contextual inputs at scale, helping ensure the AI gets the most relevant info without you having to manually tweak everything constantly.
That's powerful. And this is just critical for effective domestic violence crisis response, isn't it?
Absolutely. An agent needs to remember previous conversations with the survivor, details shared, resources already offered, maybe if they're a repeat caller.
So it doesn't ask the same questions over and over.
Right. It needs to pull in up-to-date local resource availability, current shelter vacancies, legal aid times, transport options. And while securely managing sensitive implicit data like general location for local resources or interaction history for consistent support, it must uphold strict privacy protocols.
Non-negotiable.
This whole methodology transforms a basic stateless chatbot into a highly capable, situationally aware system, one that can offer truly personalized, consistent support, adapting intelligently as the situation unfolds and a survivor's needs evolve over time.
Okay, so the agent has processed the context, it's thought through its response, using maybe chain of thought. But often, you don't just want free-form text back, right?
Usually not, no, especially in automated systems.
You need data that your other systems can actually use and act upon. This is where requesting structured output becomes indispensable.
It's about getting predictable, machine-readable data.
Exactly. Explicitly asking the AI for its output in specific formats like JSON, XML, maybe CSV, or even Markdown tables. And providing a schema or an example of the structure you want is key here.
Guides the model.
Right. The benefits are huge. It forces structure, helps limit hallucinations by giving the model a rigid target, and enables seamless integration into your data pipelines or other apps. Makes the output instantly actionable.
Yeah, it's much more reliable for automation.
Now, a really powerful technique for enforcing this structured output and seriously enhancing interoperability is using a Python library called Pydantic. Have you worked with this?
Oh yeah, Pydantic is fantastic. Great for data validation.
Right. It's a data validation and settings management library using Python's type annotations. By defining a Pydantic model, you create a clear, enforceable schema for your desired data structure.
It basically gives you an object-oriented layer on top of the raw output.
Exactly. It transforms that raw text or semi-structured data from the LLM into validated, type-hinted Python objects. The source even shows how you can directly parse a JSON string from an LLM into a Pydantic object using model-validated JSON.
Yeah, that combines parsing and validation in one robust step. You get clean, typed objects.
Super clean. And for XML, you can use libraries like Xmltodic to convert it into a Python dictionary first, then pass that to a Pydantic model for parsing, maybe using field aliases to map things correctly.
So what does this all mean in practice? Well, the ability to command structured output, especially paired with validation tools like Pydantic, transforms an LLM from just a sophisticated text generator into a highly reliable data processing unit.
That's a great way to put it.
This method is invaluable for ensuring interoperability between LLM components and other parts of a larger system. When an LLM's output is neatly encapsulated within a Pydantic object, you can reliably pass it to other functions, APIs, data pipelines.
Knowing the data conforms to the structure and types you expect.
Exactly. This isn't just convenient, it's an absolute necessity for robust automation and ensuring critical data integrity in any agentic system, particularly in sensitive applications like crisis response, where data accuracy and structure directly impact effectiveness and safety.
Yeah, it's the bridge from creative text to dependable data.
Precisely.
And this is a total game changer for crisis response.
Yeah.
Imagine an agent extracting a survivor's urgent needs, their preferred contact method, immediate safety concerns into a JSON object. Then converting that into a Pydantic object validates everything fields are correct, present, adhere to the schema. This structured, validated data can then be seamlessly fed into a CRM, a resource allocation system, maybe trigger an alert to a human responder.
Ensuring critical information is never lost, misinterpreted, or incorrectly processed just because it was free-form text. It makes the AI's output instantly usable and reliable for those crucial downstream processes, speeding up aid.
Okay, we've given our agent identity, memory, taught it to output clean, structured data. Awesome. But a truly agentic system doesn't just process information, it thinks. It thinks through complex problems, often like a human expert would.
Right, moving beyond simple retrieval or pattern matching.
Exactly. And while language models excel at pattern recognition, they can sometimes struggle with multi-step reasoning. That's where these next powerful techniques come in, to truly equip them with advanced cognitive abilities. The first technique, and it's a really profound one, is chain of thought, or CHICT. This is a powerful method that explicitly prompts the model to generate intermediate reasoning steps before arriving at a final answer.
So instead of just asking for the answer.
Right. Instead of just the result, you instruct the model to think step by step. It actually forces it to show its work, mirroring how a human might break down a complex problem.
Revealing its internal logic path.
Precisely. The benefits are significant. It fundamentally helps LLMs generate more accurate answers, especially for tasks needing calculation, logical deduction, or intricate problem solving. But here's the genius part. It significantly increases the interpretability of the model's outcome.
You can see why I got the answer.
Yes. You see the reasoning, not just the conclusion. The transparency is crucial for building trust, debugging complex issues, and honestly, pushing the boundaries of AI reasoning. It's also relatively low effort to implement and improves prompt robustness across model versions.
And there are variations, right? Zero shot and few shot.
Exactly. Zero-shot CHICT is simple. Just add a phrase like, let's think step by step to your prompt. For example, if a train travels at 60 miles an hour and covers 240 miles, how long did it take? Let's think step by step. The model then spits out the math before the answer.
Makes sense.
The other is few-shot CHICT, where you provide several full examples. the input, the detailed step-by-step reasoning, and the final output. The source uses Sarah's apples problem as a classic example, showing all the arithmetic.
Okay. Are there downsides?
Yeah, the main one is output length. Generating those reasoning steps means more tokens, which means higher cost and potentially slower response times.
Trade-off between transparency and efficiency.
Exactly. And best practices include making sure the final answer comes after the reasoning, and for single answer tasks, setting the model's temperature to 0 for greedy decoding.
So it picks the most probable path consistently.
Right, makes it deterministic.
So this is where we explicitly nudge the AI to reveal its internal mind. It's fascinating how a simple instruction unlocks more robust problem solving, making decisions more transparent and trustworthy.
How would this apply in a crisis situation evaluation?
Well, imagine the AI assessing a complex situation risk factors like abuse severity, kids involved, available resources, legal implications. COT can guide it. It could prompt the AI. First, identify immediate safety risks. Second, list available local resources for these risks. Third, consider legal implications like restraining orders. Fourth, suggest communication strategies based on the user's needs.
So it ensures a thorough, structured process.
Exactly. A structured, transparent decision process, not a black box response, which is vital in these high-stakes environments.
Okay, building on chain of thought, we have self-consistency. This aims to boost reliability even further. How does it do that?
Well, instead of relying on just one reasoning path, it generates multiple, diverse reasoning paths for the same problem.
Ah, okay. So it tries solving it multiple ways.
Exactly. It uses a higher temperature setting, which encourages the model towards more varied, creative outputs to produce several distinct co-operative approaches. Then it looks at all the final answers.
And picks the most common one.
Right, via a majority vote. It's like having a panel of experts tackle the problem independently and then agreeing on the most consistent solution.
That sounds much more robust.
It dramatically improves accuracy and coherence, especially for tasks where multiple valid reasoning paths might exist or where a single attempt could easily go wrong. It gives you a kind of pseudo-probability for the answer.
What's the catch? Sounds compute intensive.
That's the main disadvantage, yeah. Significant cost. You're running the model multiple times for the same query, generating several thought paths. Much higher computation, much higher expense.
So you'd reserve this for really critical decisions.
Absolutely. Where accuracy is non-negotiable or the stakes justify the extra resources.
So for critical advice in a domestic violence situation.
Right. An agent could use self-consistency. Say the question is, given user's context, X, Y, Z, what are the safest next steps? The agent could generate, say, 3 different step-by-step safety plans, maybe each emphasizing slightly different factors based on its varied reasoning.
And it compares them.
Yeah. By comparing them and finding the common, most robust elements, it helps choose the most widely applicable advice. It mitigates the risk of relying on a single, potentially flawed reasoning path, paramount when survivor safety is the top priority.
All right, next up, step-back prompting. This sounds interesting. How does it enhance reasoning?
The core idea is to first ask the LM to consider a general principle or a broader concept related to the task before you give it the specific details.
So you zoom out before zooming in.
Pretty much. The response to that broader, more abstract question is then used as additional context when solving the original specific problem. It's like stepping back to see the whole forest before focusing on one particular tree.
What are the benefits of doing that?
It allows the model to activate relevant background knowledge and wider reasoning strategies it might not otherwise use for a very narrow question. This often leads to more accurate, more insightful answers because the model isn't just reacting to superficial elements in the immediate prompt.
Encourages a kind of critical thinking,
Yeah.
grounding it in fundamentals.
Exactly. The example given is, first ask, what are the key factors that make a good detective story? Then use that generalized response about plot, character, suspense as context to write a short plot summary for a new mystery novel.
Ah, ensuring the summary hits the right notes based on established principles.
Right. For a domestic violence crisis agent, this could significantly improve the quality of advice. Before advising on a specific legal issue, the agent could first step back and define general legal rights for survivors in that jurisdiction, or maybe general principles of safety planning.
So that broader understanding provides a stronger framework.
Precisely. a stronger, more accurate framework for answering specific, nuanced questions about an individual situation. It ensures advice is grounded in the broader legal context or established best practices, preventing the AI from getting lost in a specific detail and missing the bigger picture of effective support.
And finally, in this reasoning section, we have tree of thoughts, or TOE-T. This sounds even more advanced. How does it extend chain of thought?
It extends CoT by enabling the LLM to explore multiple reasoning paths concurrently, using a tree structure. Each node in the tree is a thought, or an intermediate step.
So instead of single chain, it branches out.
Exactly. It allows for branching into different lines of reasoning. Crucially, it allows backtracking if a path looks unpromising and evaluating multiple possibilities before committing to a final solution.
Like the AI running its own internal brainstorming session, exploring different options.
That's a great way to think about it. And that's critical because complex problems often don't have one single linear solution path.
When is this particularly useful?
It's especially suited for complex problems needing exploration, backtracking, or evaluating multiple possibilities. It lets an agent consider diverse perspectives and potentially recover from initial mistakes by investigating alternative branches in its thought tree.
The source mentioned creative writing.
Yeah, like develop 3 different possible endings for a story based on these plot points. TOE would let the model explore distinct narrative branches from a key turning point, offering more creative and diverse outcomes.
Okay, this is where it gets really interesting, I think. These advanced reasoning patterns, CoT, self-consistency, step-back TOE, they transform the AI from just a responder into a thoughtful, deliberate problem solver.
Capable of navigating complexity with almost human-like consideration, this is absolutely key for robust, intelligent agents in high-stakes scenarios.
And for your work in crisis response, imagine using TOE for complex planning, like develop 3 different potential safety plans given specific constraints, no car, limited funds, certain family members involved, maybe geographic limits.
TOE could allow the agent to explore distinct, viable strategies simultaneously. It could identify the pros and cons of each, evaluate feasibility, and then present the most appropriate options.
Ensuring the survivor gets the most tailored and effective support, considering multiple angles for their unique situation.
Exactly. A much more comprehensive and personalized outcome.
Okay, amazing. So our agents can think deeply, they understand their role, they give us clean, structured data, but a truly agentic system doesn't just think it does.
Right, it needs to act.
It actively interacts with the world, both digital interfaces and sometimes even the physical environment. It needs hands and senses to go beyond conversation and actually take action. So, a crucial ability for any agent is using external tools or calling functions. This lets it perform actions beyond its internal text generation capabilities.
Things it can't do on its own.
Right. Web searches, database access, sending emails, doing complex calculations, interacting with external APIs. Basically anything that isn't just generating text.
How does that process work? Is the AI just call the tool?
Not quite directly. Modern LLMs are often fine-tuned for function calling or tool use. They learn to interpret tool descriptions, what the tool does, what parameters it needs.
Okay.
Based on the user's request, the model determines the tool is needed, identifies the right tool, and then formats the required arguments in a structured output, usually JSON.
Ah, so it outputs the instructions for using the tool.
Exactly. The crucial part is the model doesn't execute the tool itself. Your agentic system, the code you write around the LLM, processes that JSON output, actually executes the tool, calls the real API, runs the calculation, and then provides the result back to the model as new information.
Got it, like a feedback loop.
Precisely. For example, user asks, what's the weather in London? Model outputs JSON tool code, get current weather, parameters, city, London. Your system calls a weather API with London and feeds the temperature back to the LLM for the final response.
That makes sense. And for a crisis response agent, this capability is truly transformative, isn't it?
Absolutely. It moves the AI from being just a passive information source to an active helper.
It could use a resource lookup tool to find real-time shelter availability or legal aid slots data that changes constantly.
Right, or a send secure message tool to alert a human responder if things escalate, or send pre-approved info to a survivor, like a link to a safety plan.
It moves beyond giving information to actually doing things that directly provide assistance and connect survivors to tangible help.
Okay, building directly on tool use, we have REACT, which stands for Reason and Act. This sounds like it combines the thinking and doing parts.
It does. It's a really powerful prompting paradigm that combines that chain of thought-style reasoning with the ability to perform actions using tools, but in an interleaved manner.
Interleaved, meaning back and forth.
Exactly. It mimics how humans operate. We think through a problem verbally, maybe just in our heads, and then we take actions, look something up, ask someone to gather more information or make progress.
Ah, okay. So how does the React loop actually work?
It's a continuous cycle. First, the model generates a thought. This is like its internal monologue explaining its current understanding and its plan for the next step.
Okay, the reasoning part.
Right. Then, based on that thought, it decides to perform an action, often using one of its available tools. It outputs the tool name and the necessary input parameters.
Like the function call we just discussed.
Precisely. Then, your agentic system executes that tool in the real world and provides the result back to the model as an observation.
Got it. Thought, action, observation.
And that loop continues, thought, action, observation, until the task is complete and the model outputs a final answer. It's incredibly dynamic.
Wow. So it can really adapt on the fly.
That's the beauty of it. This interleaved process allows the agent to dynamically gather information, react to tool outputs in real time, and refine its approach based on new data. It makes it super effective for tasks requiring interaction with dynamic environments or external knowledge sources.
This really feels like the true essence of an agent. Not just answering questions, but actively engaging, probing, making moves.
Yes, it transforms the AI from a passive knowledge base into a proactive helper. Exactly what you need for practical, impactful solutions in complex, unfolding situations like crisis response.
Can you walk through that crisis response example again with React?
Yeah, sure. Imagine the loop. Thought. Okay, the user needs urgent shelter. I need to find current availability in their specific area. Action. Calls the local shelter availability tool with the user's general location. Observation. The tool comes back. 3 shelters nearby. Shelter B has immediate beds. Address is 123 Main St. Thought. Great, got shelter info. User also mentioned needing safe transport. That's the critical next step. Action. Calls the secure transport tool for a ride voucher using a 123 Main St. as the destination. Observation. Tool responds. Voucher generated. Secure link is voucher.linkxyz. Final answer. The agent confidently tells the user, okay, shelter B at 123 Main St. has immediate beds. Here is a secure voucher for transport. Voucher.linkxyz. Please go safely.
Wow. That orchestrates a whole dynamic real-world response, tying together multiple actions to achieve that complex goal of immediate safety and transport.
Exactly. That's the power of React.
Okay, so beyond specific tools calling APIs, agents are now being designed to directly interact with software interfaces, like graphical interfaces, like a human would.
Right. Yeah, exactly. Clicking buttons, typing in fields on a screen. This is a huge leap from traditional automation that needed rigid APIs or custom scripts for everything.
How does that even work?
Yeah.
It's powered by something called agent-computer interfaces, or ACIs.
Right. The core concept is the AI interacts directly with a computer's graphical user interface, GUI. It perceives and manipulates visual elements, icons, buttons, text fields, just like we do. It moves beyond needing a developer to write code for every single interaction point.
That sounds incredibly complex. What are the stages involved?
It involves several sophisticated steps. First, visual perception. The agent captures the screenshot. It sees the screen. Then, GUI element recognition. It analyzes that image to figure out what's interactive buttons, checkboxes, input fields. Then, contextual interpretation. An ACI module interprets these elements in the context of the task. Like, it understands a magnifying glass icon means search.
Okay, so it understands the visual language of interfaces.
Right. And finally, dynamic action and response. It programmatically controls the mouse and keyboard clicks, types, and constantly monitors the screen for feedback, dynamically responding to changes, like waiting for a page to load.
Are there real-world examples of this yet?
Oh yeah, several powerful ones. OpenAI's ChatGPT operator aims to automate tasks across desktop apps, transferring data between a spreadsheet and a CRM, booking travel across websites, filling out complex online forms. Google's Project Mariner is a research prototype acting as an agent within Chrome, understanding intent to do web tasks like finding apartments, applying filters, browsing, extracting info.
Right.
Anthropic's concept of computer use empowers their model, Claude, to be a direct user of the desktop environment. It can orchestrate workflows across multiple unconnected applications. Think analyzing a PDF, doing spreadsheet calculations, generating a chart, then pasting it into an email draft, all using the normal GUI.
That's incredible, spanning different apps.
Yeah. And there's even an open source library, Browser Use, providing a high-level API for programmatic browser automation. It lets AI agents interface with web pages by controlling the document object model, DOM, the underlying structure helping turn unstructured web data into structured formats.
So, for a crisis organization, what could this mean?
Imagine an agent that can autonomously navigate various state and local government websites, which often lack good APIs to pull up relevant legal aid forms, maybe input anonymized survivor data into a secure online portal for tracking, or search various community sites for available support groups.
Without needing custom integrations for each site.
Exactly. It drastically reduces manual overhead for staff, increases efficiency, and ensures survivors get info and assistance from diverse sources much faster. It lets human responders focus on the human connection.
Okay, going even further now. Beyond the screen, AI agents are increasingly designed to interact with complex, dynamic environments, sometimes mirroring the real world itself. This needs more than just digital hands. It needs real-world senses.
Yeah, sophisticated perception, reasoning, and even actuation capabilities.
What are some projects pushing these boundaries?
Google's Project Astra is a big one. It aims for a universal AI agent using multimodal inputs, sight, sound, voice, to understand and interact contextually. It focuses on rapid understanding, reasoning, response. It can see and hear through cameras and mics and have natural conversations about its surroundings.
Wow, like a real-time assistant that perceives the world.
Kind of, yeah. Then there's Google's Gemini Live, which makes AI interaction much more fluid. You can speak naturally, get responses with minimal delay, interrupt, change topics. It incorporates visual info via phone camera or screen sharing for context-aware discussion. Advanced versions can even perceive tone of voice and filter background noise.
Tone of voice. That adds a whole new layer.
Huge layer of nuance. OpenAI has its GPT-4o model, the O for Omni. It reasons across voice, vision, text with incredibly low latency like human response times, lets you have real-time conversations, maybe show it a live video feed to ask questions, use it for instant translation.
The latency part is key for feeling natural.
Absolutely. And their ChatGPT agent framework allows autonomous internet navigation, dynamic code generation execution, interfacing with third-party apps, orchestrating complex workflows like market analysis and generating a presentation, with safeguards and user authorization, of course.
Right, safety first.
And Microsoft's Seeing AI app is a great practical example for people who are blind or have low vision. It uses the phone's camera and AI to offer real-time narration of surroundings, objects, text, people.
Amazing accessibility tool.
And Anthropic's Claude 4 series offers advanced reasoning and analysis with robust vision capabilities, processing images, charts, documents. Great for complex, multi-step tasks involving detailed visual analysis.
So this is really the convergence of digital and physical capabilities, leading to proactive, context-aware AI companions.
It really is the true frontier. Think about the power of an AI that understands language and perceives its environment visually and audibly. The potential for truly adaptive, personalized support is immense, extending way beyond chatbots into real-world assistants.
It definitely makes you pause and think about the shift, doesn't it? From typing commands to an AI actually seeing and hearing the world.
Absolutely. Now, for crisis response, direct physical interaction needs very careful ethical consideration.
Of course.
But imagine an AI companion with explicit, fully informed consent and super rigorous privacy controls that could potentially help a survivor securely document visible injuries via camera for legal purposes, providing objective evidence. Or an AI that could audibly guide them through a complex legal form by seeing the document and giving real-time, step-by-step instructions. And that ability to interpret tone of voice or filter background noise, like in Gemini Live, invaluable for an AI interpreting distress calls, helping it gauge urgency and emotional state more accurately for a more empathetic response.
Okay, we've covered the mind, the senses, the hands of an agent. Incredible stuff. Now let's look at the actual construction blueprints. How do we put all these powerful techniques together? How do we build complex, multi-agent systems to tackle ambitious goals, like supporting domestic violence crisis organizations effectively?
Right, moving from concepts to actual implementation tools.
First, let's talk about some core building blocks you'll encounter. LangChain and LangGraph. LangChain is probably familiar to many already.
Yeah, it's widely used. Known for its LangChain expression language, or LCEL.
Right, LCEL, which is essentially a way to chain components together, models, prompts, parsers. Allows them to be piped into linear sequences, forming directed acyclic graphs, DAGs, meaning the process flows one way, no loops, like a recipe.
Good for straightforward stuff. Simple retrieval augmented generation, RAG, retrieve prompt, answer, summarization, data extraction where the flow is predictable, and it's generally stateless per run. Each execution is kind of independent.
Okay, so then what's LangGraph?
LangGraph is a library built on top of LangChain, specifically designed for more advanced agentic systems. It really extends LangChain's capabilities.
How so?
It lets you define workflows as graphs with nodes, functions or LCEL chains, and edges that have conditional logic. Crucially, it enables cycles.
Loops.
Loops, retries, flexible tool calls that can continue until a task is done. And unlike basic LangChain, it explicitly manages application state. The state is passed between nodes and gets updated.
Which makes it ideal for
True multi-agent systems, plan and execute agents, where the agent makes a plan, does a step, updates the plan based on the result, or complex human-in-the-loop workflows. Anywhere you need memory and adaptation within the process.
So this is a critical architectural decision then, LangChain versus LangGraph.
Absolutely. It's the difference between that simple assembly line, LangChain, and a sophisticated factory floor with feedback loops and dynamic routing. LangGraph. LangGraph unlocks the ability to build truly intelligent, stateful, agentic behavior that can persist goals over time, essential for complex domains.
So how do you choose? When should you use LangChain?
Choose LangChain when your application has a clear, predictable, linear flow. No need to loop back or maintain state across multiple turns. Simple pipelines.
And LangGraph.
Choose LangGraph when you need your application to reason, plan, operate in a loop, like repeatedly using tools, reflecting on results, maybe trying again differently, or coordinating multiple subagents. Anywhere you need cycles and state management.
Okay, so for your crisis response application,
Right.
if it's a simple flow like extract info, summarize for a report,
LangChain might be fine.
but if your AI needs to repeatedly ask clarifying questions, search for resources built on new info, check back with the user, maybe coordinate multiple AI specialists, one for legal, one for shelter.
Then you need LangGraph's ability to handle loops and manage state across those complex, iterative interactions. It lets the agent adapt and respond dynamically as the situation unfolds. Much more robust and responsive.
Okay, but what if you don't want to build every single node and edge in LangGraph yourself? What if you want to orchestrate a whole team of specialized agents that already kind of know how to work together?
Yeah, moving to a higher level of abstraction.
That's where frameworks like Google's ADK and Crew.ai come in, offering predefined patterns for multi-agent collaboration. Let's start with Google's ADK, the Agent Development Kit.
Right. ADK is a high-level, structured framework specifically for building and deploying apps composed of multiple interacting AI agents. It's more opinionated, more production-oriented for orchestrating collaboration.
How does it contrast with LangGraph?
It abstracts away a lot of the low-level graph construction. It provides pre-built architectural patterns for multi-agent interaction, like sequential agent or parallel agent. It's really architected around the concept of a team of agents, often with a primary agent delegating tasks. State and session management are handled more implicitly by the framework.
So the analogy holds. LangGraph gives you the tools to wire up a custom robot team. ADK gives you the factory assembly line for a fleet of robots that already know how to work together.
That's a pretty good way to put it. The source shows a simple example. Creating an L agent with a Google search tool, told to respond using web search, shows how easily tools slot in within the ADK structure.
And for a large-scale crisis response system,
ADK could be really valuable. Managing a sophisticated team, an intake agent, a resource matching agent, a secure data logging agent, ADK orchestrates their collaboration to handle complex cases efficiently and reliably. Multiple specialized AIs working in concert.
Okay, then there's Crew.ai. How's that different?
Crew.ai is another orchestration framework, but it specifically focuses on collaborative roles and structured processes. The conceptual model directly mirrors a human team, making it quite intuitive.
What are its core components?
3 main things: agents, tasks, and the crew. Agents are defined by persona role, like legal analyst, goal, even a backstory for context. Tasks are discrete work units with clear descriptions and expected outputs assigned to agents, and the crew is the whole unit agents, tasks executing a predefined process.
And the process can be.
Sequential output of one task feeds the next. Or hierarchical, where a manager-like agent delegates and coordinates tasks among specialists. It operates at a higher abstraction level. You're designing a team charter, not wiring a state machine. Focuses purely on the logic of agent collaboration.
So for crisis response, you could define a triage agent with an empathetic backstory.
A resource coordinator agent with expertise in local services, maybe a follow-up agent for long-term support. Crew.ai orchestrates them sequentially or hierarchically to provide comprehensive multi-stage support, mirroring how a human team might work. Ensures holistic assistance.
Got it. And beyond these, there are many other agent development frameworks popping up, right?
Oh yeah, it's a rapidly evolving space. You've got Microsoft AutoGen, Agent Conversations, LemonX connecting LLMs to data, great for AdJet, Haystack scalable search, MetaGPT multi-agent systems via SOPs, Hyper AGI, autonomous agent lifecycle management with a GUI, semantic kernel for Microsoft integrating LLMs with code via plugins planners, Strands agents from AWS, model-driven approach, lots of options.
It really is a spectrum, from fine-grained control like LangGraph to highly abstracted teamwork like ADK or Crew.ai.
Exactly. The right choice depends entirely on the complexity and scale of the problem you're solving. But all these frameworks are pushing the boundaries of agentic AI, offering powerful tools for developers like you to build increasingly sophisticated and impactful systems.
And looking ahead, even how we build these agents seems to be transforming. Forget writing every single line meticulously. Imagine just conversing with an AI assistant to generate complex software.
Yeah, this idea of vibe coding.
Right. It sounds intuitive, conversational, iterative.
All of the above. It's an interaction where the developer provides a high-level goal, a desired vibe, or a general direction, and the AI generates code to match that intention.
So instead of detailed specs, you use conversational prompts like create a simple, modern-looking landing page with a calming aesthetic.
Exactly. The AI interprets the vibe, and it's built on iterative refinement. The AI's first output is just the starting point. You give natural language feedback? Good start, but make the buttons softer blue or add some error handling here.
So it becomes a creative partnership. The AI suggests ideas, accelerates development.
Leading to potentially more innovative outcomes. Yeah, developers focus on what, not how, leaving implementation details to the AI. Great for rapid prototyping and exploring ideas.
And you can use optional memory banks to keep context for longer conversations. Store preferences, constraints.
Right, to ensure consistency across multiple terms.
This paradigm is getting really popular with powerful models like GPT-4, Claude, Gemini integrated into development environments, isn't it?
It is. It's fundamentally changing software engineering, shifting focus from syntax memorization to creativity and high-level thinking. It's a fascinating evolution. Really blurs the line between developer and AI, turning the AI into a true creative collaborator.
It shifts focus from tedious implementation to innovative problem solving.
Which is exactly what we need for urgent, impactful solutions, allowing developers to bring their vision to life much faster.
So imagine using vibe coding for your crisis response AI. Create a Python module that securely logs survivor interactions to an encrypted database, ensuring anonymization.
Oh.
Or develop an API interface for the local shelter database, make it robust, handle and work errors gracefully, prioritize privacy.
It allows you to rapidly iterate on solutions, focusing on the impact and the user experience for survivors and responders, rather than getting bogged down in boilerplate code. You bring creative solutions to life faster, directly benefiting the organizations you support. #outro.
Wow, what an incredible journey today. Seriously, from refining our prompts for unprecedented precision, all the way to building entire multi-agent ecosystems that can see, hear, and act.
Yeah, in the digital and physical world.
We've really taken a deep dive into the agentic design patterns playbook, seeing how this whole toolkit comes to life.
Indeed. We've explored how those foundational prompting techniques scale up to handle complex reasoning, how structured output ensures reliability and interoperability, and how these powerful frameworks enable real-world interaction. It's a pretty comprehensive toolkit for building truly intelligent, impactful systems.
Systems that move beyond just responding to proactively assisting.
Exactly. Deliberative assistance.
And for you, listening, as you continue to develop solutions for domestic violence crisis response organizations, we really hope this deep dive has shown how these advanced concepts and architectures directly equip you to build even better AI solutions. Your existing prompt engineering skills, they're not just a starting point.
No, they're the perfect launchpad.
The perfect launchpad for this next level of AI development, empowering you to build systems that are not just intelligent, but truly agentic in their profound ability to help when it matters most. So, as you step into building these sophisticated agents, maybe consider this. If an AI can be trained to deeply understand human intent and act with such precision, how might we push the boundaries? Could we move beyond just responding to crises to perhaps even intelligently anticipating and proactively intervening to prevent them, always through ethical, context-aware systems that respect privacy and autonomy, of course?
That's a powerful thought. And maybe to add to that, if AI agents can so effectively mimic human collaboration and reasoning within these frameworks, what new forms of human-AI partnership might emerge? Could we tackle our most challenging social problems not just with technology alone, but with a true collective intelligence, one that amplifies our uniquely human capacity for empathy and action in ways we've only just begun to imagine?